it's probably something wrong with me, but after all these years and working with this stuff, I still get excited about talking about it, no matter what it is. So today we are going to talk about link local addresses, because we're going to start working our way up into dynamic addressing with router advertisements and that, and really see some cool things. So let's get started. Hope everybody's doing well on this day. All right. Yeah. Oh, got to change. I got the wrong date there. Well, it's new though. Okay. So, link local addresses. First of all, for a device, when it's enabled for IPv6, an operating system, it's got to have a link local address. That's what it does. That means it's enabled for IPv6. To be IPv6 enabled, you only need a link local address. You don't need a global unicast address. Now we're going to see how this link local address comes into play today. Okay. At least I want to show you where it gets used, and that will lead us into, hopefully we'll get to it on Thursday, if not definitely next Tuesday, router advertisement messages. This is the core of how devices automatically get their global unicast addresses. The link local addresses play a significant role. So they are part of, we look at our IPv6 roadmap here, address type roadmap, it's a unicast address, okay? Unicast addresses, first of all, a source address is always a unicast, okay? It can't be anything else, okay? It's gotta come from a single device. That's for IPv4 and IPv6. The destination can be unicast, multicast, or any cast for IPv6, okay? There is no broadcast. There's something similar, all IPv6 device multicast, but I'm not going down that rabbit hole quite yet. Wednesday, Thursday. God, I'm thrown off. I don't know what it is. So unicast includes a link local address, is a unicast address. Okay, so I'm gonna talk all about this, but unicast means it's an address can only be used on the link, means not past the router. The router will not forward link local addresses. Matter of fact, if the operating system on the router is doing its job, it should drop any packets, not just with a it should drop, first of all, it won't forward any packets with a destination IPv6 address that's a link local. Will not forward them out that interface. And if it's doing its job, if it is forwarding a packet that has a global unicast address as the destination IPv6 address, that global unicast address is on another network, but the source address is link local, it should drop the packet. Okay? Should not permit it. Okay. So we're gonna see the role of link local addresses. Don't worry about all this, but we're gonna see how it's used in router advertisements, how devices get its IPv6 global unicast address. We'll also see this end devices use the link local address of the router as its default gateway in that process. We'll see later, I'll show you an example of doing routing with IPv6, and routers exchange messages with each other, routing messages, using their link local address. So the key thing with link local means, so let me bring up my ink to go. I'm gonna have to turn it off soon after. It messes up my Zoom for some reason. So a key part about link local addresses is if we have a PC here, let's put a switch here, that's just a switch, another PC here, and let's make it a router here. I don't know, how should I make my router? I'll make it a circle like this. That's kind of what we do here. That's a router, okay? Link local addresses, LLA, okay? They're only good for this link, not past the router. Basically, if this device knows the link is trying to communicate with the router via its link local address. It knows, hey, you're on my link. Okay. I know you're not someplace else. Okay. I know this is not for something on another network. This is for something on my network. We will see later that when we have two routers communicating with each other, talking to each other, meaning we haven't talked about this. I talked about this in my CIS 82 class and 83 classes. Routing protocols. They're going to exchange routing information, what they know about remote networks. Well, they do this talking to each other's link local addresses. And the reason they do that is they say, it's like an extra added guarantee that you're on my link. You're not. You're on a shared network with me. So that's the whole benefit of the link local address. We will see here in a moment that the end devices, we'll see this later today and more later in the next couple of classes. The default gateway address that a device uses for IPv6 is the link local address of the router. Yet the router will have what's known as a global unicast address. Also, we'll see that in a moment. Okay, but the global unicast address is globally routable. Why is the default gateway typically the link local address? It definitely is when this client learns about it dynamically. We'll get there. Why could it use the global unicast address? Yes. But there's one thing that the link local address guarantees. You are local. I don't have, let's say, some reason due to misconfiguration, I put this global unicast address as the default gateway. That would be a problem, right? Could you do it? Yes. I could assign a default gateway address for IPv4 or IPv6, an address on the other side of the router or even another router. Okay? We shouldn't do that. Okay? Link local means I'm guaranteeing that I'm on this link with you. You don't have to worry about this being this address, like a global unicast address or an IPv4 address, being somewhere else. All right. Hopefully that makes a little sense for you. All right. So link local address begins with the first 10-bit. This is trivia stuff. Okay, but it's good to know, or good to be exposed to. You're going to see it sometimes written as, let's see here. Let's see if I've got this here. I'll show it here in a moment. But it'll be written as FE80::/10. What this means is the first 10 bits have to be 4 1 bits, 3 1 bits, and then it doesn't matter. Or I'm sorry, 4 1 bits, 3 1 bits, a 0 bit, 1 0, and then it doesn't matter. These first 10 bits. Okay. So if I had all zeros here to all ones, so what we're looking at is actually this hextet here. Okay. Each hexadecimal digit, we have 4 hexadecimal digits. Okay. FE80. So they both say yes. F, E, E. Okay. But these next two hextets can vary from 8, 0 to BF. It just says these first 10 bits have to be this. Okay. This is more than I really want to spend on this. But what I am saying is this. Use FE80. You can use anything in this range, FE80, FBF, but don't. The reason why, you never know about the operating systems. The client operating systems may not support anything but FE80. Why? Just kind of, a little sloppily written. Okay? You just never know. There's no reason not to use FE80. Okay. All right, so let's talk about how link local addresses are automatically created. Because let me show you on this computer right here, Packet Tracer. Okay? I'm going to do IP config here. And notice it doesn't have any addressing information. Well, that's not exactly true. It doesn't have an IPv4 address. It's configured to get everything automatically. No DHCP server. No IPv6 address, not getting anything automatically. But it does have a link local address. It created it itself. Every operating system will create its own link local address automatically. Now you can change it and make it statically, and we'll talk about that in a moment, but it created it automatically. Now there's two ways it can do it automatically. Okay, first of all, it's going to use FE80 here. Okay, and then that's what the first 64 bits are going to be. FE80 and then a bunch of zeros. So all we really care about is the interface ID. Okay, the interface ID, it can use either something called EUI64, which this is what Cisco routers do, or can use, and also, by the way, that's what Packet Tracer uses on end devices. I got to get them to change that. Or random, and this is what your most client and operating systems will do, and I'll show you mine in a moment. Yep. Or you can statically configure it, and yes, you will. It's a good idea to statically configure it on routers, and we're going to see why here in a moment. Okay, let's talk about EUI64 first. Okay, random is pretty easy. EUI64 stands for Extended Unique Identifier. What are they talking about? Well, what they mean is this. Here's an Ethernet MAC address. Yes, it uses the Ethernet MAC address. It takes the device's Ethernet MAC address and says we have the organizational, there's two parts of an Ethernet MAC address. The first 24 bits is known as the organizationally unique identifier, the vendor, Intel, Cisco, HP, 3Com. 3Com still around? I think so. And then you have, this is the unique identifier right here, the last 24 bits. Okay, but this in total only gives us 48 bits. We need 64 bits for an interface ID. So we're going to extend this unique identifier. We're actually going to push this over a little bit. So what we're going to do is we're going to divide it in half, and we're going to insert FFFE, 16 bits. That makes our 48-bit MAC address now 4 plus 4 plus 4 plus 4. There's our another 16, makes it 64 bits. Okay, but we're not done yet. Okay, one other thing happens. See over here, we're going to change this from hexadecimal to binary. The 7th bit here, it has a long history I won't go into, but it's known as the universal local bit. That bit gets flipped. Okay, and it's just basically saying that something's been changed here. So notice that this second hexadecimal digit here got modified. Okay, so this is going to be the interface ID for our link local address. We'll see that also can be similar when a device creates its own global unicast address. We'll get there later. Okay, for now, link local address creates its own interface ID. Okay, so you can, well, let's actually take a look. Let's not just use PowerPoint, let's actually do it. Okay, let me move this out of the way here. Okay, so let me bring up my text editor because I think that'll make it a little easier. Put that right there. All right, so here is my link local address. Well, let me copy that. I'm going to put it in my text editor. I'll make that bigger. Okay, all right. Now notice I can tell. In fact, let me ask you, can you tell if this was created randomly or EUI64? there's a really good, strong hint. That means most likely, without even knowing the Ethernet MAC address of this device, something in here tells me that looked like it was created using my MAC address using EUI64. And if you want to just put in the chat or just speak up, it's up to you. Or nothing. Is there anything in there? Ah, look at this. Remember that FFFE right there in the middle? When I see that in an IPv6 address, chances are that was created EUI64. Now, how can we make sure? Let's do ipconfig /all. This will show us the MAC address of the device. Okay. There we go. Here's the MAC address. Okay, so let me copy that in. Copy that here. Okay. And let's see if that got, oops, let's see what happened. Wait a minute. Oh, that's my Bluetooth. Okay. Come on, where are you there? Did I not do /all? Come on. Why aren't you showing me the MAC address? Oh, it's right there. I'm sorry, physical. There it is, right there. Jeez, Rick. All right. Sorry about that. There's the MAC address. You saw that, right? You just didn't want to make Rick look bad.
It's just early, Rick.
Thanks, Pamela. Make me feel good. Okay, there we go. There's the MAC address right above it. I'm looking everywhere down here. Okay. Does it slightly different on Packet Tracer than Real OS? All right. No. Okay, so let's see what happened here. Okay. So how did it take this MAC address and turn it into this? Okay. Well, we said it's going to insert FFFE, right? That's what it did. It inserted FFFE. Of course, it writes it a little differently, but there's the FFFE. Okay, so that's got inserted. Then it took, so remember we have a leading zero omitted there. So let's just put that in just so we see it. It then took this second, come on. Second hexadecimal digit, took actually the 7th bit through here and flipped it. So that got changed. Oh, I'm sorry. Took that second hexadecimal digit and flipped it. Okay, so that's what happened. So we got flipped that, and that's how we got it. So that's how we got, let me put that back in. That's how we got from there our MAC address to our EUI64. Yep. Does that make sense?
Yes.
All right. So that's how we got the 64 bits. All right. Move that out of the way. Let me show you. By the way, so Cisco routers. Yeah, let's go take a look at the router. So most client operating systems, back to this here. Most client operating systems now, though, however, use a randomly generated address. So, okay, and how can you tell? Well, I don't see any FFFE in the middle there. Now, we're going to talk about this here in a moment, the zone ID. There's a benefit, and we'll talk more about this when we talk about why we never want to use, not why we never want to use, why it's common for client operating systems not to use a MAC address. this process called EUI64 that we just took a look at, we will see later that devices can actually create its own global unicast address, do it using the same method. But we tend not to want to do that for our client devices because, long story short here, if I use this same process using my MAC address to create my own global unicast address, that's a globally routable address. Okay, so I grabbed my MAC address, inserted FFFE, flipped this bit here, okay? And then let's say I'm on this network here. Don't put there we go. Say I'm on this network here. Okay, this is my network. This is my host. Okay, great. Now let's say I go to another network. Okay, now I'm on this network. Different network, same host. I'm on another network. Okay, I'm just going to use this one because it's common. Deadbeat. You see that out there. Sorry, I hope that's okay. But point is, same interface ID. This is using a 48-bit MAC address, which should be globally unique. May not always be, but good chances are you're not going to find that very often, if anywhere. You can be tracked. No matter what network you're on here in the world, they say, oh, that's the same computer. So that's why we don't like to use this. We will talk later about how global unicast addresses, we want this to be random and we want it to change every so often. And we'll get there a little later. Okay. Now I'll show you on my computer here. So on the computer I'm on right now, here is my link local address, see right there. So I'm on a Mac. I said IF config. Now I said EN7. This is my wireless interface. In case you're not familiar with this command, don't want to hide anything from anybody. See, I have all these. I did just IF config. Where are we here? IF config. I'm going to see everything. My loopback and a bunch of other stuff, a bunch of internal addresses that my operating system uses. But this is right now, I'm on the wired interface. I'm not on wireless. This is a wired Ethernet interface. Okay. Okay, I'm not going to go down that lead. Okay, I'm on my wired interface, EN7. That is actually my Ethernet. That's not this cable here. I didn't disconnect myself, but I'm on a wired Ethernet port that is natively connected to IPv6. FE80. Can you tell if that was random or EUI64? Can you tell if it's right? Can you tell that is random?
Yeah.
Yeah. And how's that? There's no what?
There's no the F and then the FE.
Yeah, that's right. No FFFE there. Exactly. And we'll talk about this in a moment. Notice how that aligns with this. Yeah, we'll talk about that in a moment. All right, so we saw it on the PC. Let's take a look at our friendly Cisco router. Okay, so if I do show IPv6 interface brief. Okay, you notice I have on both sides, I have a global unicast address, different networks. Okay, different networks. There's that network /64, different network /64. Okay, then all zeros and a one, all zeros and a one. Link local address. Okay. Can you tell if this link local address was created EUI 64 using the MAC address or randomly?
It wasn't random, right?
Yeah, it was not. Okay. Now, is that 100% guarantee? No. Could you have a randomly generated address that put FFFE in the middle? Wow. Yes. I would start playing the lottery. Okay. I don't know if that's good luck or bad luck. But we can show interface gigabit 00, and we can see that here is the MAC address. And just look at the last 6 digits there. 6 hexadecimal digits. Yeah, it's the same, right? All right. By the way, I do show running config. You'll see I configured both these interfaces with global unicast addresses. Now, we typically want our routers to have link local addresses that we recognize. Why is that? Now, this is getting into what we're going to be talking about later. But I talked about how devices can create their own global unicast address automatically using something called a router advertisement from the router. Now, what I'm going to do here is config T. I'm going to have this router start issuing what's called router advertisement messages. We're going to get there a little later. That's what this command does. What it does is it advertises out this interface and this interface. Hey, I'm an IPv6 router. And by the way, I'm letting you know what network you belong to, and I'm your default gateway. So let's go over to this device here. Okay, and let's see if, look at this. Now it has an IPv6 address. Okay. Now, what it did was this router here, we'll talk about this more later, advertised this network. It says you belong to this network, create your own interface ID. Just like this device created its own interface ID using EUI 64 for the link local address, it did the same thing for the global unicast address. Again, that's not something we typically want on our clients, okay? Again, because I can be tracked. If I move this computer to another network, same interface ID. Now, what I also want to show you here is this router advertised itself, I'm your default gateway. It sent a packet. The source IPv6 address of the router advertisement message was this router's link local address on that interface. Here's the router's link local address on that interface. Remember? Let's do it again. Show IPv6 interface brief. Here's the route on gig 00. It says, here's my link local address. I sent the router advertisement out with this as my source IPv6 address. This PC said here, it said, great, that's your source. I saw the router advertisement come from that source IPv6 address. That you're a router, right? Oh, well then here, I'm going to grab that source IPv6 address and use it as my default gateway. That's kind of ugly to look at. Okay, if we're doing some testing or want to look, if you're on a device and you want to try and, this is you're an IT person. You want to SSH into the router, or you want to ping the default gateways. You want to look at ARP tables, whatever. You don't want to look at stuff like this randomly or EUI 64. You want something that's going to be something you can remember. Okay, so let's do this. On router R1, I'm going to say interface gigabit 00. Oops, no, I'm not. There we go. I'm going to say IPv6 address, and I'm going to configure the link local address to be FE80:1. Okay, whoops. Incomplete command. That looks like a link local address. So Cisco iOS goes, Rick, I know it's a link local address. It can only be a link local address. I want to make sure you know it's a link local address. So they force you to put link local after it for no other reason than that you are configuring a link local address. A lot of these commands were written many years ago, and basically, people were new at this and still are. So there we go. Now I'm going to do something else here. Link local addresses only have to be unique on the link. Okay, what does that mean, Rick? Can I do this? Interface gigabit 0/1. Whoa, what am I doing here? I was here, now I'm here. Can I give it the same link local address? Link local address only has to be unique on the link. You're probably thinking, yes, Rick, because you got it there, you got it there. As long as it's unique on that link, we can do it. Okay. So now if I do show IPv6 interface brief, I'll see that, yes, same link local address on two different interfaces. As long as this address here is unique on this link, we're good. And as long as this link local address is unique on this link, we're good. Now let's go back to our PC here, and I got to do the magic of packet tracer. I think if I do it like this, let's see. Go from static back to automatic. Let's see if that works for us here. Let's do ipconfig now. So what I did was I went back to static, went back to automatic. When I did that, by the way, when I went from automatic to static back to automatic, this device, we'll talk about this in the coming days, it's this class or two, it sent out what's called a router solicitation message. It says, hey, is there a router out there, IPv6 router? Send me a router advertisement message. Tell me what network I'm on. I need to know if you're what your address is my default gateway. So that's why it changed. And look, it did change. Look at our default gateway. That's a lot easier. Hey, can I ping it? I can. That's the good news. The bad news is Packet Tracer doesn't actually implement this like it should. Everybody still with me? Because I'm going to show you on my computer here now. We good? All right. Now I'm going to show you. Oh, where's my terminal here? All right, let's go back here. Okay, so I have a link. I can ping any link local devices on my network. Okay. Now, what I need to do is show you my default gateway. Now, there's things I could do. I could do this like, let me go here to, there's ways I can just go here and go here and go. You see, there's my global unicast address. There's some details I can show you. I can get it. There's my router, so I can show you my router IPv6 address. It's a link local address. Okay. So I can do this using the GUI. Okay. But what I'm going to do is show you some different, I'm going to show you how I can get it using Mac OS, which is similar to Linux. One thing I do like about Mac OS over Linux has some incredibly cool IPv6 commands. I'll be utilizing those later. Oh my God, I was playing with those over the weekend. So a couple of ways I can get the default route. I can say netstat. Now netstat is a common command on Windows, Linux, Mac OS, all that stuff. When I say Mac OS, we can kind of think Linux. -nr. And so netstat tells me all kinds of things about processes and my connections and network status of my device. All kinds of stuff. If I did it all by itself, well, let me show you. I mean, this will go on for a while. IPv4 and IPv6. Come on. Yeah, it'll go on for a while here. Let me break out of that. So what I'm going to do is say netstat-nr grep default. This is actually just going to show me my default routes. So I'm looking for a default. So there's my IPv4 default route. Here's my IPv6 default route. And there's that EN7 again. Now,
Are you connected? Are you connected to AWS? I see EC2. Is that
sure? Yeah. Yeah,
Okay.
a lot of stuff runs in the cloud. Yeah, most of show you a little program I wrote later, Python, that will show you everything that you're connected to, and most of the stuff now, it's all in the cloud. Yeah, there's not as many dedicated services, and like there used to be. Even Cabrillo, anything to do with Cabrillo, all of our Cabrillo stuffs is a cloud provider. Most of it's AWS. So if I do ping, let's ping that default gateway. First of all, in Linux, I have to use ping 6, okay? In Windows, it's smart enough. Ping says, okay, I'll figure out, is that an IPv4 address or IPv6 address? But I have to use ping 6. So I'm going to ping my default gateway. Okay? Now here's my default gateway. It's a link local address on my router. Okay, I can't talk and do this at the same time. FE80.828:1. Okay, so I configured this on our local router. Oh, I'll even show you that here in a moment, okay? So you can see how all of this works. Okay, so this actually I made this specifically. Okay, so this is actually has to do with VLANs. It shows what network I'm connected to. And this is the total link local address, FE80 : and then these 64 bits here, all zeros, F828:1. Okay, can I ping it? No, I can't. It says no route to host. Here's the problem. Okay, link local addresses. Let's look at a perspective of router. Okay, if the router wanted to ping a link local address, okay, let's go back to this router real quick. Okay, remember, here's the link local address of our device. Let me go ahead and copy this. If our router wanted to ping that link local address, okay, no, it's asking me a question. It's saying, great, you want to ping a link local address, Rick? Which interface is it out of? Because that link local address, there's nothing in this link local address that tells me what network it belongs to, because it doesn't belong to a specific network. It just has to be unique on that network. This address could exist here, could exist here, could exist in both places. That's fine too. I need to know, router R1 says, I need to know, do you want me to send the ping out this way or this way? Oh, I need you to send it out the gigabit 00 interface. So let me tell you that. Well, here's a lazy program. This gets me. There's a couple of commands in Cisco iOS like this. It says, sorry, you've got to give the full interface name. Really? Yes. All right. Gigabit Ethernet, and no spaces, by the way. 0/0. Okay. There we go. Yeah. So I actually had to type all that out. No spaces. Then it says, yes, sent the ping. Oh, and it replied. Okay. So link local addresses. Let's go back to this example here. It has to know what interface this is out of. So when I do ping 6, I actually have to put it's out. There's a couple of different ways you can do this in Linux. Or Mac OS Linux. I actually have to put %, meaning this is the interface, EN7. Now I'm pinging my default gateway. There's other ways I can do this command. I can use in the ping, where are we here? The ping option. I can actually put after ping 6 space -I for interface and put EN7, and then just put this by itself. Okay. But I have to tell it what interface to send this out of. Okay. How are we doing? Are we doing okay?
Mm-hmm.
All right. Let me show you one more thing and we'll take a little 5-minute break. So what I'm going to do is I'm actually going to show you this. Why not? So what I'm doing right now is I'm logging into it's actually a layer 3 switch. You can think of it as a router, but it's a group of layer 3 switches. By the way, my CIS 82 class next semester, we're going to be learning a lot of stuff that's in here that you're going to be seeing. So let me connect. Okay. And I have learned, I'm moving this to another screen, I'm going to put in the password. Not that it shows, but let's put away and do that here in a moment. I have been on many presentations. I have seen presentations where somebody is, oh, password, and they start typing and they realize they're not here, they're someplace else, and they start showing everybody the password. Okay. All right, I'm in. The next thing I'm going to do here is enable. Okay. Okay. So I'm going to show you show IPv6 interface brief. Okay. And what you're going to see is this is the interface I'm connected to. I'm going to move this off to the side for here for a second. I'm going to do a show running config, and somebody has a username and password in there that is not properly encrypted. No fault of theirs. And so I just don't want to accidentally show that. So what I'm doing is going through this real quick and to show you how I configured that. And this is the kind of stuff we are going to be talking about in CIS 82. These are called VLAN. This is called switch virtual interfaces. We'll learn about that CIS 82 if this is something new to you. But you can see that, think of it similar to a physical interface. This is the IPv4 address on that interface. Here's the global unicast address. This is global. This, by the way, this is Cabrillo College. Okay. This is the room number 828. VLAN has its own room, which I'm connected to that same VLAN. So we have a this subnet /64, right? So here's 16 plus 16 plus 16 plus 16, 64 bits. This is how the internet sees Cabrillo. And this is my subnet that I'm on here at Cabrillo. It's that easy with IPv6. We have 18 quintillion devices. This is the global unicast address. Okay. Now we have a firewall. So it's not like anybody can just get in, these are reachable from anywhere in the internet. This is the link local address on that interface. When this router, called a layer 3 switch, but router, sends out its router advertisement, it's sending it from this source IPv6 address. Okay. And I'm going to show you that in a moment after we take the break. I'm going to run some Wireshark here so you can actually see that address. Okay. But this is all real stuff. It actually really does work. All right. So let me move that off to the side. And let's take a 5-minute break. Everybody doing okay? Yeah, John.
So is there a way that you can hint to get for your link local address to say, okay, you're going to be an FE80, but I want you to make me a trailing number. So instead of the FE80 : and a 1 being your gateway, basically it's advertising saying, guess what, FE80 blah is your local network, link local network portion of the address. Can you give it a hint so your link local address scheme matches a specific what do you call it? Specific network, and you got.
Can I add? Here's the network I'm on. Could I put that inside the link local address?
Can you put something, like a number? This is my local network number 1. This is my local network number 2. So you don't have to specify the interface. When you specify your link local address that you want to ping, it actually can verify, okay, it's this network, which means it's this interface, because much like you do in IPv4, you have a 192, let's say, for example, 192.168.1 versus a 192.168.0 for your networks. You've got an FE80, and you want to add a prefix or a suffix for the network portion of the address.
You can, but it won't make that. It won't make any kind of assumption about that information.
Okay, so
it's because there's nothing in this address. There's nothing in it that makes it routable. The only thing that you could do is one thing you can do, it's very common in IPv6, is you use names instead of numbers. So you can have like your own name to IP address mapping. So you can so you can ping a name of something, and it gets it resolves. But nothing you can do. There's nothing you can do in the address itself.
No, not the address. You were talking about the router. You had two interfaces. They both had, you could say both use FE80, and you could say the gateway would be FE80::1. And that's valid because each address is unique on that particular network.
Mm-hmm.
If you said the gateway was FE80, let's say, :00:00:1, and then on the other interface, and then some address, :::1. Then on the second interface, you've got FE80:0:0:, get my numbers right, let's say 2:::1. You've specified the network portion for the gateway. Will the clients on that network that get that information saying this is my gateway, will they adopt that as their link local portion of the network?
No.
No, okay.
Yeah. But you brought up a good that I am going to get to. Let me just, if you notice here, and you brought up a good point, so I'm glad you mentioned this. Where's my, if you notice, this is all the same router. If you notice, I did not use the same, like I did here, the same default, the same link local address on both interfaces. Here we did not. Okay. Here what I did was they're all .1, but they're using really what we call the VLAN number. Let me just quickly show one thing, and then we will take a break here. A good way of doing this, a better way, instead of having FE80::1 on both and FE80::2 on both, and this doesn't this isn't a solution to what you're asking, but it is best practice not to use the same link local address on both interfaces or all interfaces. It's not a problem. It's just that what you can do is you can do things like, I had this coming up here. Yeah. What you can do is, say, for example, this is FE80. this one here, you could say maybe this is router 2, so you give it a 2 here. And then this is on this is on the 2 subnet, this is on the 3 subnet. I mean, it's nothing automatic. But what it does is you can start saying, okay, I know the default gateway. If I see FE80 on a device, FE80 :2 3, I know it's connected to router 2 and I'm on the 3 subnet. So there are addressing things you can do to help manage things a little easier. What I did here was I just used just a :1, but I prefaced it with whatever VLAN. We'll learn about this later, but these are just network addresses, subnets, followed by a :1. So it doesn't take care of your problem, but it does allow for better address planning, management, and recognition of what your addresses are and where they're at. Okay, I'm going to let me do a 5-minute break. I'll be online. If anybody wants to ask any questions. I've got to run something here on Wireshark. Let's take 5. And by the way, you guys have one job, one important job. Remind Rick to restart the recording.
Recording stopped.
I will probably get timed out of that. So let me just go ahead and close Zoc anyway. Yes, okay. Oh, let me start the 5-minute timer so Rick remembers. Okay, I'm coming. I'm coming. Yeah, I'm looking for something. Start the recording so I don't forget.
Recording in progress.
Okay. Thank you, John. Yeah, John, you got me looking for something. I wanted to show you something you'll remember. John and I used to work together years ago at Santa Cruz operations. So John was boy, John, I don't know if I'm sure you know that, but you always looked at as the person to ask. Boy, when it came to anything Unix internals or any of that stuff. So it helped me out a lot when I got there. Yeah, well, you still are. You're your Unix Linux stuff. John used to teach. Did we call it? Was it Linux or Unix when you taught here at the class here?
It was Introduction to Unix and Unix sysadmin.
Okay, all right. It was still Unix. Okay. Did we didn't use SCO Unix at the time, did we?
Yeah.
We did.
Unix and SCO Unixware.
Oh my gosh. Oh yes, those were the days. Okay. You did a great job too. All right. So what I want to show you is this is a router advertisement message. Make that nice and big. So I ran Wireshark and wanted to show you that the router, I'm going to close all this. The router art that we just looked at was sending out a router advertisement message every 200 seconds. That's what Cisco defaults to. Now I'm going to show you my home router later, the difference. Okay, but I want to show you. So here's the IP. First of all, show you the Ethernet. Here's the source MAC address of the router. We'll be talking about this. This is the destination MAC address. This is a multicast address. Okay, this means actually 3333 means it's a IPv6 multicast, Ethernet frame. We'll talk more about that actually on Thursday. But it's staying, look, if your device is enabled for IPv6, your network interface card will accept these Ethernet frames. And this specifically has to do with IPv6. And this is a special multicast, not a broadcast, but kind of the same thing, because this specific one means all IPv6 devices. Now, if I look at the IP packet, okay, here's the packet itself, the IP header. Okay. Now, the destination address is also known as a multicast, IPv6 multicast. Similar to what we just saw from the Ethernet, this means all IPv6 devices. So that means, oh, okay, my device needs to accept this and look at it. Now, here's the source IPv6 address. Does that ring a bell? It should. Let me bring up my terminal here. Okay, if you remember, that's my default gateway. The source IPv6 address of this router advertisement. My computer saw that and says, great, you're my default gateway. Because you're a router advertisement, you're a router. You're my way out. It's like getting a letter from your local post office and looking on the outside of the envelope and go, now I know where my local post office is. Now I know where I can bring letters that are for another neighborhood. All right, that's cool. Let's look at the router advertisement a little bit. Okay, so so first of all, it says, oh, what data am I carrying inside this packet? The next header field, similar to what's called the protocol field in IPv4, says, what I'm carrying is ICMPv6, type 58. Great, let's take a look at what that is. So My operating system accepted my NIC card accepted the frame, passed it on to IPv6. How did it know to do that? Because the type field in the Ethernet header said, hey, the data I'm carrying is IPv6. Oh, okay. So my Ethernet process said, here, data, go up to IPv6. Sends the data up to IPv6. IPv6 looked at all this stuff. It says, okay, what do I do with it? Oh, the data is ICMPv6. Let me remove this. Hey, here, data. Here, ICMPv6. Here's the data. This is the router advertisement message. So one of the things I want to show you, a couple of things, but we'll look at this in much more detail later. Let me kind of close all these things. Okay. All right. So see these little, this is Wireshark. See the little greater than symbols? That means there's something that can open up. So it's a router advertisement message. Okay, we'll talk all about this stuff. Here are some flags. We'll talk more about these flags in a moment. They're all set to 0, not in a moment. The next week. Managed address. We'll talk about these managed address and other config. Okay. I want to move down here. Here, prefix information. This is where the router is letting my device know, hey, this is the network you belong to. You belong to 2607 F380 ADF F2800, F828 all zeros /64. Okay? And it also told it this. See this little flag right here? Called the Autonomous Address Configuration Flag. That's just a fancy name for saying, hey, I told you what network you're on. You create your own IPv6 address using this network address. That's what this flag here says, the A flag. Create your own address. Okay? And my device said, oh, okay, great. And you told me you are the default gateway. So I have that. Well, you didn't tell me. I just looked where it came from. I looked at, I found your address. You're the source. So you're going to be my default gateway. And now you've told me what network I belong to. You told me to create my own interface ID. And my operating system says, okay, I'll do that. I'll do that. So using, I think I got enough room here. Using this prefix you gave me, great. I can create myself one or more addresses. And how did I do that? Looks like I just did them randomly. Okay, which I did. Now you're going to see I have 2 random addresses here. 2 global unicast addresses. Okay, same network. Just the, yes, you got it. The router advertisement told me, but I created 2 different, my operating system said, I'm going to create 2 different addresses, each one with a different interface ID. And what it did was it created one that's called temporary. So when my device sends packets out, this is the address it's going to use. I should say out. Let me back up, Rick. Let me state that more accurately. When my device initiates the connection, okay, meaning I went to Zoom, I went to Google, I went to Facebook, I went to Netflix. Wherever I'm going, I went to Cabrillo's website. I'm going to use this address. Okay, and that's what they'll use then, because they'll have my address and they can communicate with me. Great. What about this one? When does that get used? I can open up my firewall if I want and say, this is a permanent address. This device will always have this address. So if you want to connect with me, you can. Now I can have that change whenever I want, but that's more of like, you know, an address that I want certain devices to, like, when I'm acting more as a server in that case. Now this one down here with this is also random. This will change every so often, so I don't get tracked. Whether it's random or MAC address, if they don't track me, hey, that's the same PC that was there, all over these networks, all over the world. Nope, this will change. So I can't get tracked. Let me see if I can show you something real quick here. You will see and I'm just going to show you some just random packets here. This is my current connection. Okay, so you can see I'm sending a lot of UDP stuff, probably has to do with Zoom. But see this address here? Okay, this is what, look at this here. This is coming from my device, going out to some public address, and it's coming back from that public address back to my device. No network address translation. Public to public. I am unique. We're all unique. But my global unicast address is unique and doesn't need to be translated. Yep. How we doing? This making sense? Okay. All right. Well, I got too many windows open. All right. I want to mention a few things. Wanted to mention here. Yes. I want to mention. Yeah, it's this command here. Let's go back here to packet tracer. I want to make, there is a command that people think you need to use to enable IPv6. So let me mention something here. There was a command, if you remember, I initiated here, IPv6 unicast routing. Now I'm able to create on this router IPv6 addresses. I had done that previously, no problem. Global unicast addresses, no problem. But the router will not act as an IPv6 router until I've done this command. What does that mean? What this command does is two things. One, it says, if I get packets for IPv6, let me move that over here. If I get packets and I'm let's say running a routing protocol or static routes, that packet has the destination IPv6 address maybe over here. I'll look at my routing table. I know where it is, how to get there. I'll forward it on to the next hop router, like IPv4. Okay. So it allows the forwarding of IPv6 packets like a normal just IP router. Okay. Without this command, it won't forward packets to other networks, to remote networks. It won't check static routes or dynamic routes in its routing table. The other thing it does is it starts sending out router advertisement messages. That's what we just took a look at. Okay, that's what all that stuff. Hey, this is the prefix you belong to. Create your own address, whatever. This used to be a command that used to be required for IPv4 many years ago. I'm aging myself here. Probably at least 25 years ago. And then they said, no, there used to be a similar command for just regular IPv4. Why? because Cisco routers years ago routed for any kind of protocol, not just IPv4. Maybe you weren't running IPv4. Maybe you're just running IPX. So why, so you had to enable which routing protocols at the time, because there were, or which network layer protocol you were routing for at the time, because there were several besides IPv4. The reason why you do it now for IPv6 is because, most likely because of the, letting you know, you're going to start sending out a router advertisement, advertising yourself as the default gateway, saying, and allowing devices on your network to create their own global unicast address using that information. So it's not on by default. I would imagine there will be a point where they'll make that change, but that will be, anytime you make a change to a default in the operating system, you got to remember people upgrade their operating systems, and if they're not aware of that default, I mean, if this was the default, then all of a sudden all their end devices are going to have global unicast addresses if the router has an IPv6 address, a global unicast address. So it's just something, that's a big, change if they ever make this the default, which I think that eventually it will be. Any questions so far?
Are you gonna post this packet tracer lab on?
Yeah, I can post this
Okay,
packet
thanks.
tracer, the startup file. Yeah, no problem.
Rick, if we're like absorbing maybe 75 to 80%, is that problematic, or is it sort of like some other times in the CIS 81 class?
No, I mean, you're doing great. If you're absorbing 75%, you're doing great.
Okay.
Just this, like my 81 class, we're going to talk all this stuff. You're going to hear about it more and more, even in this class here. And I'm glad you brought that up, Pamela. This is one of the things, especially in networking. I always tell students the introduction to networking class is one of the hardest. Not because the content is hard, it's new and it's a lot of stuff, and it's the first time. You remember, I go back to, grade school. And I remember, I had trouble telling time, analog clock back in those days. And I was a little boy, and I'm like, oh my gosh, how am I going to get this? Quarter till, half past, 30 minutes. What is all this? The hands, where, and I remember my dad made a big cardboard clock and showed it to me, and we went through it. And he told me, he said, Rick, you're going to be telling time so much. You're going to be looking at clocks so much. This will become what seems difficult now, be no problem, because you'll be, the more you're exposed to it, the more familiar it becomes, so it'll become like second nature. That's networking. So, and there'll be two things in networking. I'm so glad you brought this up, because it's something I try and tell all my classes. There'll be some components of whatever you're learning that you will see over and over again. Okay. And we'll talk more about all these things like link local addresses and that, and you'll see it in context with other things. But there will be some other things that, it's on an as needed and if ever needed basis. You're exposed once or to it maybe. And if you need to go back, at least you saw it before, but it's just kind of add it to the bigger picture and then let it it drifts away. And that's okay. That's okay too. I've got probably literally hundreds of content that I've developed over the years. Do I have all that stuff in my head? No. I have to go back and refresh my mind on stuff. Even this stuff, I have to go back and refresh my mind on. So yeah, that's normal what we do in this business. Okay.
Thanks, because it's almost like a different way of thinking. At least for me, it feels like it. So I appreciate that explanation.
Yeah, no problem. I mean, as far as networking, or the IPv6 is a different way?
Both.
Both, yeah.
But I like IPv6 a lot more. So yeah, networking overall though.
But great point on that, Pamela, that it is a different way of thinking. So this, and it was, many years ago that they came up with this. So it's not like this is just over the last 5 years. But when they decided to, we're going to develop a new IP protocol and not use OSI CLMP to replace IPv4, they looked at, okay, what else do we need to do besides a longer address? So what they did was in IPv4, you're very limited. Okay, if I bring up as something as simple as, and bring up my Mac here, network, okay, connection, details, okay. Here for IPv4, I have basically DHCP or static. That's it. Okay. Now IPv6, they added more knobs. They call it, they just say automatically. Why is that? Because you can see there's a lot of different options. Okay, that router advertisement says you can create your own, or we'll use a DHCP v6 server, or both. These are just knobs. And as I always say, and this is from what I've learned from others, simple is better than complex. You keep it simple. Why is the complexity there? In case you need that knob. You have that as an option if you need that in your environment, in your scenario. Okay? Start simple. Don't make it more complex than you need it to be. But if you have a requirement that you have that flexibility with IPv6. IPv4, not so much. IPv4, you have two options for a device getting an IPv6 address, or IPv4 address. You statically configure it, or you have to have a DHCP server on your network with a pool of addresses that gives all that information out. And a router. Now, typically they're the same device, but that router's acting as a DHCP server and has to have that ability to do that. Okay. You got to configure it, or if it's a home router, let me show you that. My home. I always have trouble finding this here. Sorry, give me 1 second. I'll show you on the home. Oh, I always have trouble finding the home router on here. Okay, and devices, not there, not there, not there. There we go. If you have a home router, it does DHCP for you. Okay, by default. So here's our little home router. Okay, I go to the GUI, and it's already pre-set up for DHCP. Okay, but you've got to have that. Okay, so it's got to do DHCP, or you've got to set it up if it's not pre-set up and all this. Yeah, IPv6, they just made it simple. They said, you have the ability to have a globally unicast address, a globally routable address. And all you need to do is connected to a router that gives you access beyond your network to the internet, let's say. You have access to the internet via router, you've got an address by itself. So you don't have to do all kinds of special configurations. If you have, think about, if you have hundreds, thousands of devices out in your agricultural fields out there, sensors and things, they can get their own addresses just by connecting to the router. That's, just where they're getting their signal from. So anyway, I went on way too much on this, but it's a great question because we want the ability, but we want to keep it simple. Just use what you need. So I'm just trying to show you that there's a lot of different possibilities out there. Okay, and we will see some other things. They did make it a little bit more going on. Some people say that's been a benefit to IPv6. Some people think it's been a detriment. The people that have the hardest time with IPv6, it's the people that have been doing IPv4 a long time. But I remind these seasoned network engineers that if they're, from kind of my generation, when I got involved in this stuff, there wasn't just IPv4. We were doing all kinds of different protocols, so working with another protocol now, IPv6 is really, just part of, it's nothing new. Now, what has made our life a little bit more complicated is networks in general have become more complicated. The whole TCP/IP stack, security, routing, end devices, it's what we expect of our networks is a lot more complex today than it was 10 years ago, especially, or 20 years ago. So yeah, what we do with our networks and what we've added and the protocols, and we'll talk about a lot of this in CIS 82. We'll be taking basic networking and how to implement it in an enterprise network. I think that's all I've got for today. Let me just quickly check to make sure there's nothing I left out with Link Local. I think I covered everything I really needed to cover today. Yeah, I'll post this. So if you want to use this, you can. You can use it with the recording and play with it. But yeah. All right. So I will see everybody on Thursday, and we'll do a little introduction to multicast. Okay. Make your
Thanks.
head
Have a good
spin a
one.
little bit more. Have a great one. Have
You
a good
too,
day,
thanks.
everybody.
Bye.
Bye.